Hello everyone, welcome back to another video. So in this video we'll be discussing the editorial for Codechef Status 175, and I participated in day 1 and I was able to solve first two problems, so we'll only discuss editorial for first two problems. And these two problems will be second and third in due 2, and in due 3 due 4 I'm not sure what was the where were these questions numbered. But in D1, I performed pretty well, I would say, because I got a rank 8 among the rated participants, that is, among all the 5-star participants. And I got rank 25 among all the participants, which includes 6 and 7-star participants. So you can check this rank, and here my rank is 25 among all the participants. So I would say this was a pretty good contest for me. So let's just discuss the problem tutorials. So the first problem was alternate it, which was in which we are given a binary string s, and we can perform any number of operations on it, but those operations are constrained by the numbered operation. So if we are performing an odd numbered operation, that is first, third, fifth, we can shuffle any substring of s in any order. And if we are performing even numbered operation, then we can choose a substring and flip every bit. Flip means if a character is 0, we can make it 1. If it is 1, we can make it 0. So what we need is we need to find the minimum number of operations to make the string alternating. Now alternating is just a string where adjacent characters are not equal. So alternating string starting from 1 would be 1 0 1 0 1 0, like this. You can also start from 0, something like this. So these are alternative strings. So we are given binary strings and we need to find minimum number of operations such that we can make the string alternating. So for example, in first example it's 110010. Now this can be converted into an alternate string by performing one operation, that is, we can shuffle the whole string and we can rearrange it as 010101. Now this is already so this is alternating, so we required one operation. Second string is already alternating, so 0 operations. Now on third string, what we did was we did not perform any we perform first operation where we choose empty substring, that is, we did not make any changes in its order. And during second operation we flip one index. We flip index 4, which was 1 initially, and then it became 0, and the resulting string was 0 1 0 and 0 1. So we in which we took two operations. So this was the question. Let's start with some observations. Uh, Alternating string observations, first of all. In alternating strings, if the length is even, if the string length is even, then number of ones would be equal to number of 0, because of alternating string would be something like 0 1 0 1 0 1, and we are considering that the string length is let's call it frequency instead of length, and we are considering that the string length is even. So we will have to make sure that frequency of 1 is equal to frequency of 0 if it is an alternating string. This is, we are not talking about order right now. We are just talking about frequency of 1 and zeros. Now, else when n mod 2 is 1, then frequency of 1 and frequency of 0, one of them must be n plus 1 by 2, and one of them must be n by 2. So let's say I have a alternating string of length 7. There are two possible options, that is 0 1 0 1 0 1 0, and other is starting from 1. So here frequency of 1 is 3, and frequency of 0 is 4, and here it is alternating, frequency of 1 is 4 and frequency of 0 is 3. So in simple terms, we can break the frequency condition to one condition, that is the absolute frequency of 1 and absolute difference between the frequency of 1 and 0 should be less than equal to 1. So for so this condition will satisfy both our solutions. So for both our cases, for n equal to even and n equal to odd, both the conditions will be satisfied by this single condition, that absolute frequency of 1 and 0 must be less than equal to 1 for an alternating string. Now you might also ask that if the string is even and the frequency will be 1. Now that is not possible, because let's say there are x ones in the string uh, of length, alternating string of length even, and there would be n minus x. Now absolute difference, if you consider x as uh, odd, this will also be odd, and if you consider x as even, this would also be even, and absolute difference of two same parity numbers would also be even, and the only possible case for this would be 0. So we don't need to worry about uh, other condition if we just check this condition itself for frequency. Now if the frequency is not according to our requirement, in which operation we can make it equal? In second operation, in even numbered operation, we can make it we can satisfy the frequency uh, problem. Now once we solve a frequency problem, we just need to reshuffle it according to our requirement. So performing one even number operation, and if required performing the later operation, that is to shuffle the characters. So first operation, then we performed second operation where we fix the frequency according to our requirement, and then we are at third operation where we reshuffle it. Now you might say that in second operation, what we can do is we can flip a substring. So only one operation would not be enough. But if we want to minimize the operation, and we just need just want to make one even numbered operation, then what we can do is in first operation where we shuffle the string, we can make sure that all the characters which are being flipped come together, so that in single operation we can flip them. So let's say if I had four ones, and this would be not a good example. So five one, I have five ones and 1 0. This is an example. Now what I need to do is I this is also not a good example. Let me just try to create one example for better understanding. Yeah, let's just stick with this example that we have five ones and one zeros. Now what we need is we need to flip here the frequency of one is 5 and frequency of 0 is 1. What we need to do is we need both of them should be equal to 3. So basically what we need is two flips from 1 to 0. So I need to make sure that I flip two ones in such that it becomes 0. Then what I can do in first operation is I can make sure that whatever number of flips I am requiring, I will combine it as one substring, and I can make all the others as it is. So reshuffling at first operation, our target should be to make sure that all the flips which we are required club them together, and so that in we only require one operation of the even numbered operation, that is to flip bits. So from all these observations, we come to conclusion that we at max need three operations to make string alternating. So what are our possible operations? 0, 1, 2, 3. Now when our answer will be 0, this would be when the string is alternating itself. Now when would be the operation, when would be the answer, when would the answer of the string would 1, when we don't need to change frequency of any character, that is frequency condition is satisfying, what we need is just reshuffling. This is the case for 1. Now the case for 2 is, this is a tricky one, that is when we change frequency we don't need to reshuffle it. Now this would be the case when we only need to flip a single bit. Now if there were two bits which we need to flip, then the then they would be at adjacent elements, and if we flip them, both of them will be flipped and the adjacent characters would be equal. So this would be not an alternating string. So when we need to flip only a single bit, then our answer would be 2. And for all other cases, answer would be 3. So this was the main observation, that at max we need 3 operations, and we basically divide each number of operations in different case and find the solution for it. So let me just explain my code. So first of all, we take string s as input, and first what I'm doing is I'm checking if the string is already alternating or not. If it is already alternating, what I'll do is I will just print 0. Then what I'm doing is I'm finding absolute difference of frequency of 1 and 0. So how I'm doing it, whenever I encounter 1 I will increment cnt, and whenever I encounter 0 I will decrement it. So I will have a absolute difference between 1 and 0. Now if this cnt is less than 1, that is the frequency is already satisfied, our answer would be 1 itself. Just perform a one reshuffling operation and that's it. Now second case is where we need to flip one bit. Now that would be identified if the absolute difference between count is less than equal to 3. For even it would be 2 and for odd it would be 3. So to consider both the cases, I just did absolute count less than equal to 3. Then my answer would be 2, and for all other cases answer would be 3. So this was the first question of day 1, and reading this question itself I understood that we need to uh, somehow decrease our search space, because the maximum number of operations required would be finite and would be around would be less than 3. So coming to that conclusion for me was easier, and then I just need to break down these cases and write code for it. So this was the first question. Now second one was quite interesting. So we are given an array a of length n, and also we are given an integer x. Now we are allowed to perform the following operation at most once. So what we can do is we can choose a contiguous subarray of a and multiply each element of subarray by x. So we need to determine maximum possible frequency of any element after performing operation at most once. And frequency of element is defined as number of times it appears. That is pretty standard. So let's just take this case. So we have four number n as 4 and x as 3, and was it 6262? Yes. So without performing any operation our answer would be 2, because 6 has frequency 2, 2 has frequency 2, and max of frequency of any element. So answer is 2 without performing any operation. Now if we perform operation on this subarray, so we multiply 3 with all the elements from that subarray. So 6 remains 6, this 2 becomes 6, this 6 becomes 18, and this 2 becomes 6. Now here frequency of 6 is 3. So answer here is 3. So basically what we need to do is we need to choose a subarray and multiply it with the x such that the frequency is maximized. Frequency of an element is maximized. So idea would here would be to map 6 and its uh, for this case it would be 6, but for general case, let's say y is an element in my array. I have to find some kind of relation with its complement element, that is y by x. So for 6 I can make frequency of all the elements which are 2 to 6 by multiplying it with x. But the issue is we can choose a subarray. So whenever we choose this subarray, existing 6 would also increase by 18. So for a subarray like this, if we multiply it with x, that is we multiply each by 3, this frequency increases our answer, this decreases, and this increases again. So for 6, let's say multiply by 3 increases my answer, but the already existing 6 is getting removed and replaced by 18. So this that decreases my answer, and again this 2 increases my answer. So there is some kind of addition and subtraction type of operation, increment and decrement type of operation. So when I saw this, I thought of cadence algorithm. So what I need to do is a contiguous array such that its sum is maximum. So for 6, what I need to do is I need to iterate over indices of 6 by x, that is 2 and 6 itself. And whenever I get 6 by x, I will increment my answer. Whenever I get already existing 6, I will subtract my answer. Again, when I get 6 by x, I will add again. And whenever this value, let's say here there was 6 by x, here it was 6 again, here it was 6 again, and here it was 6 by x. So it increments here, subtracts here, again increments here. Taking this subarray is not optimal because the value itself becomes negative if I iterate from here to here. So this is a simple standard algorithm, uh, uh, standard algorithm of finding maximum subarray sum, and that is whenever we sum prefix sum or current sum becomes less than 0, we just make current sum equal to 0, because we there's no point of taking this as my subarray. I can just continue from 0 for later part. So this is just standard cadence algorithm, and what we need to do is we need to modify it in this manner of its multiplier. So how can we do that is, first of all, we have array an. Now we will create another array b1, b2, and bn, such that bi is ai into x. Now, originally our answer is the maximum frequency of all the elements in the array itself. So without performing any operation. Now, when we perform an operation, so if we take b1 as my subarray, its frequency would increase, but at the same time its frequency of its corresponding element in original array, that is ai, decreases. So for example, this 262 and its complement array, so original test case which we took, its complement array, that is multiplied by x, would be 18, 6, 18 and 6. So if I start from this, let's ignore this for now and just focus on this array. So if I start from this index, and here the frequency of 6 would increase because it is a new element, but its original respective element, it would decrease. Similarly, when we reach here, the frequency of original the new element, that is 6 into 3, increases, but at the same time frequency of older element decreases. So this is like the current uh, value which was storing in cadence algorithm. So current sum, and there was max sum. So current sum is somewhat I'm storing in a map for each element, and I'm also taking creating another map called as MP to store maximum frequency till all the indices. So after performing each operation on single index, I will also check if it is greater than current max and replace it in my origin max map. So if we consider ith element with multiplier, its frequency would increase, its bi value will increase, that is a of I into x. But at the same time, its original value, that is ai itself, will decrease. So this was a type of modified cadence, a variation of cadence algorithm. So this was my solution. So let me just go through the code. Also, there the each case overrides when x is equal to 1, because when x is equal to 1, what we perform or we do not perform operation, the answer would be remain same. So we need to handle it separately. So first of all, taking n x input, then vector array input, then I have declared another vector b as we discussed, and what I'm doing is I'm making it equal to a of I into x. Then I have also declared an OG map which stores the frequency of elements in the original array. So OG of a of I plus plus. Now if x is equal to 1, then we don't need to perform operation, because performing it or not performing it both results in same array. So in that case, I will just take maximum of my maximum frequency of from the OG map itself and print it. Now, if x is not equal to 1, then I will declare two maps. The third one is not being used, current 2, so you can ignore it. One is to find maximum frequency till now, and current is the current frequency. So I'm iterating over array and incrementing b of i's frequency, marking it with max map itself, and I'm decrementing the current of a of I frequency. Now, whenever this becomes 0, I can start counting. There is no point of taking it. So this is from cadence algorithm. So whenever some value becomes 0, contiguous value becomes 0, there's no point of taking it. So we can ignore that contiguous elements. So just make its frequency 0 again and take max of it. Now my answer will be this original frequency plus the maximum frequency after performing operation, which is stored in MP, and original frequency, which is stored in OG. This would be one of the answer, and other answer would be if some new element is being created, but that is also not required, but just in case I added it, so to make sure I consider all the possible answers, and it would be so all the elements from MP also I'm considering their frequency as also, and finally I'm just printing that answer. So this was the second question. I think coming up with this cadence algorithm was uh, main obsession, and then implementing this. I have seen some other implementations also where we store for each element of a of I, we also store indices of a of I into x, and then perform some type of cadence algorithm on it. So for each AI, I store a of I into x, indices of a of I, and also indices of a of I into x, and iterate over those indices. And as the all the indices will repeat twice only, so a of i's index in itself will be iterated once, and then for some aj into x would be a of I. So for that also it would be iterated. So something like 2 into n type of iterations on indices, and additional n log n for map and stuff. So that solution would also work, but this solution is probably the most simplified solution, I would say. So give this type of thinking a try. And talking about third, fourth, fifth. So I tried this one build some first because it was on after it was above the skip game problem during the initial contest, but as solves for skip game increased, it came above. I mean, this is kind of a greedy plus bits type of question. I tried it for around half an hour and 40 minutes, and till I remember till 9:15, that is after 1 hour and 15 minutes, there were zero solves for this question. After that, I kind of gave up, and I also tried this one, and this one has also less solves. So I gave up on that also after 15-20 minutes. Then I solved this easy unscorable problems. I got pretty good delta. So I think Codechef caps the delta even if you perform pretty well. I think there is a cap of 50 rating. I think you cannot get more than 50 rating. That's my assumption. So yeah, I think that's it for this video. I will try to upload a tutorial for more Codechef contests. And thank you for watching.